Hi guys, welcome back. We're on lesson 2 today in chapter 6. We're talking about equivalent fractions again. So remember that means fractions are equal to each other. Go ahead and find your math journal, your new math journal. We're going to be working on page 335 today. Once you get to page 335, go ahead and look at the share and show portion of this. You guys can go ahead and try these on your own if you want. It says complete the table below. So it's broken up into 3 parts. Today we're kind of moving away from models. This lesson is all about the word they use is generate, which means create. So we're going to be creating our own equivalent fractions and trying to do that kind of without a model. So the first part though, they show you the model. So they're showing you in the first one that this is showing 2 out of 3 boxes colored in, or pieces colored in. They took the thirds now and they changed it into sixths, and they're showing you that 4 out of 6 is equal to 2 out of 3, and that's what they wrote in the middle section. You guys now figure out, how is 2/3 related to 4 over 6? So 2/3, I'll write your new fraction over here, 4 over 6. How are they related to each other? Think about what we did last, I don't know when that was, earlier this week probably, and how we decided if fractions were equivalent to each other. We were multiplying or sometimes dividing by a factor. So to get from 2 to 4, we did times 2. 2 times 2 is 4. On the bottom, 3 times 2 is 6. Remember, we had to choose the same factor to get the equivalent fraction. So these two are related to each other because we're multiplying by a factor of 2. Okay, go ahead and look at the next one. You can look at the model. It's showing you 3/5 is equal to 6/10. How are they related? What are they multiplying by? I know 3 times 2 is 6. 5 times 2 is 10. So again, we're just multiplying by 2. And then the last one, 1/3 and 4/12. What are you multiplying by? This one I think is times 4. 1 times 4 is 4. 3 times 4 is 12. Okay, so that's using the model. And now we're moving away from the models. So actually for the next 2, 3, 4, 5, and 6, I have to tell you that your answers might be different than my answers. When we think about equivalent fractions and making equivalent fractions, we said you could just multiply by a factor as long as it's the same in the numerator and the denominator. You can multiply by any number you want to make equivalent fractions. I usually choose just easier numbers like 2 and 3 and 4 and 5, but I mean you can multiply by a factor of like 37 if you really wanted to multiply. As long as the factor is the same in the numerator as the denominator, your fraction should be equivalent to the original one. So like on number 2, it says write 2 equivalent fractions. You're doing 4/5 and you pick what factor you want to multiply by. I'm going to choose 2. If you multiply the numerator and the denominator by 2, your new fraction is 8/10. However, if you didn't choose 2 and you chose to multiply by 3, like I'll do on the second one, your fraction could be 4 times 3 is 12, 5 times 3 is 15, 12 over 15. You can choose literally any factors you want. You could do, watch, I'll do one off to the side. We did 4 times 100 and 5 times 100, An equivalent fraction could be 400/500ths. It doesn't matter what factor you multiply by, as long as you get the same one in the top and the bottom. So I know that 4/5 is equal to 8/10, which is also equal to 12/15. And if you did times 100, it's also equal to 400/500ths. So again, if you don't choose the same numbers as me, that's fine. Our answers will just look a little bit different. On number 3, 2/4, I'm just going to do times 2 again. 2 times 2 is 4. 4 times 2 is 8. So 2/4 is equal to 4/8. Then I'll do times 3, 6 and 12. So I know that 2/4 is equal to 4/8, which is equal to 6/12. That's all you're doing to find equivalent fractions. Number 4, 5, and 6. It just says 3/6 is equal to something which is equal to something else. So it's like this last part here. They've taken out the steps in between. So they took out the showing your work part. So if you can do this in your head, that's great. If you can't, you can show your work off to the side or on a piece of scratch paper. But 3/6, if you multiply both those by 2, 3 times 2 is 6. 6 times 2 is 12. So I know that 3/6 is equal to 6/12. You could think of another one by doing 3/6 like we did in the top times 3 now. 3 times 3 would give me 9. 6 times 3 is 18. You could do times 4, times 5, times 10, whatever you want. Our answers might not match exactly. 3/10, if I do times 2, 3 times 2 is 6. 10 times 2 is 20. Now if I start over and do times 3, 3 times 3 is 9. 10 times 3 is 30. And then number 6, I'll do times 2 and times 3 again. 2 times 2 is 4. 5 times 2 is 10. And then I'm going to use 2/5 again to do times 3. 2 times 3 is 6. 5 times 3 is 15. Okay, 7, 8, 9, and 10, though, our answers will match for this because it says tell whether the fractions are equivalent, right? Equal or not equal. I really don't have a lot of room on this one, but remember, they just have to be multiplied by the same factor in the numerator and the denominator. So 5/10 and 6/18. 5 times 2 would give me 10, but 6 times 3 is 18. Since they're not multiplying by the same factor, theirs are not equal to each other. Number 8, 4 times 2 is 8, and then on the denominator, 5 times 2 is 10. So since they're multiplied by the same factor, these are equal. Number 9, 1 times 4 would give me 4 in the numerator. But if you did 5 times 4, it would not give me 10. On the bottom, they're doing times 2. Since they did times 4 on the top, these are not equal because they're not the same factor. And then finally, number 10, 1 times 2 gave me 2. They did 4 times 2 on the bottom to get 8. So since they are the same factor, they are equal. Okay, so this is really just more of practices of what we have done earlier this week. Again, let me know if you need help with anything. If you have any questions, something you're confused about, let me know. Otherwise, I will see you guys later.